All right, this is lesson 17. We are learning all about sets this week, and in this lesson we are going to learn about what it means to be a subset and what it means to be a proper subset. So remember, last lesson we learned that a set was just a collection of objects or elements. So a subset of a set W is another set that contains only elements from W and can contain all elements of W. If A is a subset of W, we write this relation as follows. We write A is a subset of W. That's how we write our symbol. So this A here is a subset of W, which means that it only contains elements from W. It only has things that are from W. And A can contain every single element of W. If A is a proper subset that contains only elements of the original set, but not all elements of the original set. So if A is a proper subset of the set W, we write this relation, A is a proper subset of W. So it doesn't have this little equal symbol. And now it doesn't have this little equal symbol because A cannot contain all of the elements of W. So we still have that A only has elements of W, but it cannot contain every single element of W. So it can't equal W. That's why we don't have that little horizontal bar underneath. So let's do some examples. In our first example, we have A is 2, 4, 6, 8, and then we have this little ellipse. So this looks like all positive even numbers. B is the elements 4, 6, 8, and C is the elements 4, 6, 8, 10. And we want to use notation to indicate the relationships between these sets. So how is B related to A? Well, B contains elements from A, but it does not contain every element from A, right? It just has 3 positive even numbers. So B only contains some elements, not all. Elements of A. So this means that B is a proper subset of A. We write it like this. Oops, it's kind of ugly. B is a proper subset of A. Because B contains only elements from A, but it does not contain every single one. Next, we want to determine how C is related to A. Well, again, C does only contain elements from A, but it does not contain every single one. So C only contains some, not all, elements of A. Elements of A. So that means that C is a proper subset of A. All right, and next we need to determine how B and C are related. So B is 4, 6, 8, and C is 4, 6, 8, 10. So C contains one more element than B does. They are not the same set. So that means that B contains some of the elements of C. It contains 4, 6, 8. It does not contain 10. So C only contains some, not all, elements of B. This means that, I reversed that, whoops. B only contains some of the elements of C. B only contains 4, 6, 8. C contains 4, 6, 8, 10. So this means that B is a proper subset of C. Okay, let's go on to the next example. we have three sets here. X is A, B, C, D, E, F, Y is B, E, and Z is B, E, F. Which of the following is true? So A says X is a proper subset of Y, and Y is a proper subset of Z. So let's write this out. X is proper subset of Y. Y is proper subset of Z. That is what this is saying. So if that were true, I would need the elements in X to be only elements in Y. And we can see that that's not true. X contains elements that are not in Y. So this is not true, as X contains elements not in Y. So that was for A. A is not true. Okay, the next one says X is a proper subset of Z, and Z is a proper subset of Y. So let's first look at X is a proper subset of Z. That would mean that X only contains elements from Z. And we can see that that's not true. X contains A, B, C, D, E, F, and Z contains B, E, F. So X contains elements that are not in Z. So B is not true either. So X contains elements that are not in Z. Okay, what about Z is a proper subset of Y is a proper subset of X? So let's see. Z is a proper subset of Y means that Z only contains elements that are in Y. Well, that's not true because Z has F and Y does not. So Z contains elements that are not in Y. So that is not true. Z contains elements that aren't in Y. All right. D says Y is a proper subset of Z is a proper subset of X. So are all of the elements in Y also in Z? Yes, that is true. Y only contains elements that are also in Z. So I know that this first thing is true. And then what about Z is a proper subset of X? Does Z only contain elements that are in X? Yes, that is also true. So D is correct because Y only contains elements in Z, and Z only contains elements in X. So I know that D has to be true, which means that E cannot be true. So D is our answer. Next, we have an example without numbers or letters. Here we have sports. So A is tennis, football, soccer, baseball, hockey. B is soccer, tennis, and C is tennis, soccer. So remember, order of the elements does not matter. So actually B and C are technically the same set. So which of the following are true? There may be more than one correct answer. So is B a subset, not necessarily proper, of C? Well, remember, because I have this equals symbol, this horizontal bar, this means that B can equal the set C. And since B and C are the same, A is true, since B is actually equal to C. Next, we have A is a proper subset of C. This means that A only contains elements that are in C. Well, that's not true. A contains elements that aren't in C. Okay, what about letter C, which says B is a proper subset of A? Okay, well, B, this is saying, does B only contain elements in A? Well, yes, every element in B is also in A, so C is true. Everything in B is in A. And it is a proper subset since B is not equal to A. But D is also true because I can still be a subset without being equal to it, like I am in D. So both C and D are correct because everything in B is in A. Great. So the only instance where C and D would not both be true is if B was equal to A. If B was equal to A, then C would not be true, but D would be true. So if B and A were the same, then D would be true since I have that equal bar underneath there, but B would not be a proper subset of A. So C would not be true. All right, hopefully you learned a bunch today. We will continue this set stuff on Wednesday, so I will see you then. Have a good day.